Okay, good morning, everyone. Welcome, everyone. Today we are going to start list in Python. List is a very important data structure in Python. You can display sequential data using list data structures. Let's see the documentation of list by official python.org website, and then we are going to implement that using Google Collaboratory. Okay, let's go for it. So now, when it comes to programming using Python, under informal introduction to Python on our website docs.python.org/free tutorial, we are going to implement this section wherein you are going to cover list operations. Okay, let's get started with this. So when I click on lists, as you all can see here, Python knows a number of compound data types used to group together other values. Okay, so using string and integers, you can represent a single value. But when you have to represent compound data means a collection of some information. When you have to represent that information, or else you can also consider the data grouped together. If you want to represent it in Python, then we have a data structure which is most versatile, and that is known as list. So what is list? List can be written with a comma separated values. Okay, since you have to provide a group of values, you can separate it with comma, and you can specify those values within square brackets. Okay, these are the two things. So you can represent compound data separated with comma and enclosed within a square bracket. This representation is known as a list representation in Python. And then what you can do is you can quickly store this information into a variable. Okay, since programming works from left hand side to right hand side to left hand side, so you can represent your compound data at the right hand side, you can put it, enclose it within square brackets, and then you can store it into a variable. Okay, so the data type of this variable will now become the list type. Okay, list might contain different types, so it is not necessary that you are going to represent only homogeneous data with list. Python lists offer you this facility wherein you can represent heterogeneous information as well. Okay, heterogeneous means different data types can be added onto a list. Different data type means it could be a string, it could be Boolean, it could be double, it could be float. Any type of data, you can put it on a list. Okay, but usually when you create a list, the items should be of same type. Okay, usually. So mostly the objective is to represent data of similar type, but it is not necessary that you always have to store similar type of data. You can also store heterogeneous data in list data structure. Okay, so here is a simple representation that how you can quickly create a list of elements and you can put it onto a variable. Okay, so let's get started with this. So now what am I going to do? Let me keep this on one side of the screen. Okay, let's keep here. In the other window, we will be having our collaboratory file. Okay, so let me extract Google Collaboratory here. So let's get started with this. Now, what we are going to do, we are going to quickly create a new Python 3 notebook. You can click on new Python 3 notebook. Okay. So when you create a new Python 3 notebook, प्रोजेक्टर से पीछे करो स्क्रीन थोड़ा. Okay, up to the picture. Now, So we are going to give this a name. So at the top, you can see that you can quickly change the name of this collaboratory file, and I'm going to call it as lists. IPYNB stands for Interactive Python Notebook. I think you all know about it. It's an interactive Python 3 notebook. So we are going to get started with this. So click on connect. Okay, let's get connected. So now you can see that once you click on connect, you're connected to Python 3 Google Compute Engine backend, which offers you 12.72 GB of RAM and 50 GB of disk space. Okay. Now, so here we are going to get started with list. This hash tag is used for single line comment. So we are going to perform list operations. Okay. So the first operation will be create a list. So as you have already read the documentation, when you create a list, you have to create a list with multiple values enclosed within a square bracket. So let's say when you quickly create a square bracket, and let's call it as, let me save it onto a list, list one. Okay. So this is considered as an empty list. This is an empty list. And if you quickly want to check the type of this list one, you can call type function, and within type function, you can specify your variable. Okay, let's run that. So when you run, you can see that list one is of type list. Okay, so this is an empty list. Now let's add some values on the list. Okay, so I'm going to create list of actors. Okay, I would like to create a list of actors. Let me just keep it a little more here. Okay, now let's see. So I'm going to make a list of actors. Let's get started. First name will be, let's say, Salman Khan. Second will be Shah Rukh. Let's say third will be, let's say, Amir, Ranveer. Some names I have given onto a list. Okay. Let's say we have three names. I have given three names separated by commas. So here you have three strings known as Salman, Shah Rukh, and Ranveer. As you already know, we can create a string with double quotes as well as with single quotes. Okay. So once you have created a list, now you can quickly store that onto a variable known as, let's say, actors. So when we run this, you can see that a list of actors has been created. Now, if you want to quickly check the output, show the list of actors, you can quickly show the list of actors by calling actors variable. And when you run, you can see that you're going to get all the names available within the list data structure. Okay. Is that clear? So this is how you can quickly create a list of elements. Okay. As we said, here the data type of all these data which is inserted into the list is of string type. But you can also create data with heterogeneous information. Okay. Let's call it as list with heterogeneous data. So let's say I would like to create, let's say, a person. So person will have a name. Let's say my name is Devanshu. Let's say I have, my height is 5.8. So I've specified a float value. Are you a mentor? I'll say yes, I'm a mentor. True. So I've got three different data types loaded here. String. The first one which we specified is a string here. Okay. The second one, which we specified, is float. And third one, which we specified, is a Boolean value. Is that clear? So now we're going to get a list, but this time the data is in heterogeneous format. So let's check the content of person. So you can see that we have got a list created with three values. First is a string Devanshu, second is 5.8, which is double value or float value, and third is a Boolean value. Okay. If you want to quickly print, let's say, type of person, so it's of list type. So we can quickly call the function type and we can print the data. Let's run this. So when I run, you can see that person is of class list type. Is that clear? Are you all done till here? Now, so you can store homogeneous data as well as heterogeneous data in a list. Now there comes an important operation on list. Like strings, you can perform indexing and slicing on list. Okay. So indexing you already know, slicing you already know. Okay. We are going to perform indexing as well as slicing on list. But before that, I would like to take you to one resource. And this resource is going to be a list resource. So we all have to go to this website, visualgo.net. This website is going to help you understand the data structures with visual representation. Okay. I'm sharing link with all of you. Visualgo.net. Okay. Let me also update that. Under mentor notes and videos. Okay. So the objectives are, we are taking list operations in Python. And one of the resource is visualgo.net. Animated visual representation and operations on data structures. This is a very important website. When it comes to interview preparation, you can use this website so as to practically understand how algorithms and data structures are implemented. Okay. And you can understand it with visual representation. So since we are working on list, we'll quickly go to the section linked list. Okay. Let's click on linked list. And here is a list. So let's check back the definition of linked list. So linked list is a data structure consisting of a group of vertices. Okay. You can also consider them as nodes, which together represent a sequence. Okay. Under the simplest form, each vertex is composed of a data and a reference to the next vertex in sequence. Okay. Is that clear? Now, linked list and its variations are used as underlying data structure to implement list, stack, queue, and dequeue. So using list or using linked list, you can implement list, you can implement stack, you can implement queue and dequeue. So we will consider these operations as well. Is that clear? Now there are some important operations when it comes to list. First, what you can do is you can create a list. So let's say I'm going to create a user-defined list, and let's call it as 1, 2, 3, 4, 5, 6, 7. So I've got some elements 1 to 7, and when I click on go, I've got a list created here. So as you all can see, this is a linked list representation of list. In a list, you have a head, and you have a tail element. Okay, and this represents a sequence. So when you have to represent that in Python programming, then you have to specify a square bracket followed by elements 1, 2, 3, 4, 5, 6, 7, and you're going to save that into, consider it as list 1. Is that clear? So here, your list 1 actually represents this. Is that clear? So this is the visual representation. This is the code-wise implementation of your list. So now, there are other operations. What you can do? You can quickly perform search on the list. Okay. So I'll show you how the search will be done. So before search, let's do one thing. First, we are going to insert an element onto a list. Okay. पहले हम क्या करेंगे? We are going to insert an element onto a list. So what you can do is you can insert at the head, you can insert at the tail, as well as you can insert at a specific position. Okay. Let's see. If I have to insert on head, let's say I have a value known as 8 and I want to insert it at the head. Okay. So let's see how many operations will it take. So when I click on go, you can see that a new vertex has been added and the head has been changed. So this is the simple logic of implementation of inserting an element at the head. Okay. So what we need to do? We need to create a new vertex node. ओके एक नया वर्टेक्स नोड बनाया हमने नए वर्टेक्स नोड के बाद में हमने हेड चेंज कर दिया ठीक है जो भी हमारा हेड था उसे चेंज कर दिया हमने जो नेक्स्ट एलिमेंट हमने ऐड किया है उसको हमने हेड से रिप्रेजेंट कर दिया ठीक है सो दिस इज वन सिंगल ऑपरेशन ऑन द लिस्ट ओके तो लिस्ट में हमने क्या किया सिर्फ क्या किया हमने जो हमारा वर्टेक्स है उसको चेंज करके हेड कन्वर्ट कर दिया दिस इज वन सिंगल लाइन ऑफ कोड व्हिच इज एग्जीक्यूटेड ऑन द लिस्ट हेड पहले 1 को पॉइंट कर रहा था फिर हमने चेंज करके 8 को पॉइंट कर दिया कितनी सीपीयू साइकिल लगी 1 साइकिल there is only one operation which executed hence it is saying that inserting at the head is a big O of 1 operation big O of 1 का मतलब है सिर्फ एक सीपीयू साइकिल में आपका हेड आपकी लिस्ट में इंसर्ट हो ठीक है तो हमें करना क्या पड़ा सिर्फ हमने पुराने वर्टेक्स को चेंज करके हेड चेंज कर दिया ओनली वन ऑपरेशन वी हैव डन ओके सो इसको कहते हैं टाइम कॉम्प्लेक्सिटी इन वन सीपीयू साइकिल कितनी भी आपकी लिस्ट बड़ी होने दो लेट्स से 10,000 एलिमेंट्स है आपकी लिस्ट बट अगर आप हेड पे इंसर्ट करोगे तो सिर्फ एक सीपीयू साइकिल ठीक है क्योंकि आपको नई वर्टेक्स का हेड चेंज करना है बस ठीक है कितनी भी बड़ी लिस्ट होने दीजिए तो दिस ऑपरेशन इज नोन एज बिग O of 1 okay so now let me just quickly let you introduce with this what is big O of 1 big O of 1 क्या होता है is it an excellent time complexity ठीक है पहले हम इससे समझेंगे फिर हम ऑपरेशंस परफॉर्म करेंगे let's see so I would like to take you to a very nice article first and this is big O cheat sheet okay so let's say big O cheat sheet okay, यहाँ पे big O cheat sheet के ये सारे implementation है but I would like to take you to a better one here you can see big O cheat sheet.io this is one resource which you guys will be exploring as well as Okay, bigocheatsheet.com. These are the two resources. So let me first add them on your mentor card. So in interviews, mostly when you will go for a technical interview, they will always seek a candidate who will be able to write an algorithm with the minimum time complexity. Okay, hence you need to understand time complexity. समझना बहुत जरूरी है, क्योंकि जितने भी अच्छे कंपनीज के टेक्निकल इंटरव्यूज होते हैं वहां पे दे इंश्योर दे विल ओनली सेलेक्ट द कैंडिडेट जो कि मिनिमम टाइम कॉम्प्लेक्सिटी के बेसिस पे एल्गोरिथम्स लिख सकता है, ठीक है, और बेस्ट डेटा स्ट्रक्चर्स यूज कर सकता है टू ओवरकम अ प्रॉब्लम. Okay, let's see. So here we are going to specify time complexity resources. So this is bigocheatsheet.com, as well as there is one more, bigocheatsheet.io. Here you are going to have visual representation. Here you are going to get technical representation of time complexities of every individual data structure. Okay, so I've saved it. Now, so here is a big O complexity chart. Okay. Now let me just quickly introduce you with what is this. So you can see that on x-axis you have n number of elements, and in this direction your n number of elements will increase. Okay. As well as here on y-axis number of operations are represented. Is that clear? Now, the time complexity of a data structure is always plotted between how many elements the data structure has and what operation has to be performed on it. Okay, is that clear? So these are the two things which are pretty important: the number of elements you have in a data structure and the operation which you have to perform. So when you perform an operation on n number of elements of a data structure, and if you are able to write an algorithm which can perform that operation in big O of 1 time complexity, it will be considered as an excellent time complexity. Okay. Consider big O of log n. This is also considered as a good time complexity. Okay. So you should always seek कि आप ऐसे operations लिखें जहां पे आपका algorithm n number of elements को big O of 1 टाइम कॉम्प्लेक्सिटी में सॉल्व कर दे, यानी एक ही सीपीयू साइकिल में आपका एल्गोरिथम आप ऑपरेशन परफॉर्म कर सके. ठीक है, तो एक एग्जांपल ऑपरेशन का है इंसर्ट. इंसर्ट इज एन ऑपरेशन ऑन एन नंबर ऑफ एलिमेंट्स. ठीक है, सो कंसीडर हमारे पास 7 एलिमेंट थे हमारी लिस्ट के अंदर और हमें इंसर्ट ऑपरेशन परफॉर्म करना था. वी हैव टू इंसर्ट एट हेड. कितनी सीपीयू साइकिल लगी थी? ओनली 1. सो टाइम कॉम्प्लेक्सिटी क्या आई थी? big O of 1. So it was an excellent time complexity. Okay. So inserting at the head is a excellent time complexity based operation. Post that there is big O of n, which is good. Then you have big O of n log n, which is bad. Then you have big O of n square. Then you have 2 raised to the power n, and the worst is n factorial. Big O of n factorial. So n factorial is going to increase time complexity huge, because मान लो आपके पास 10 एलिमेंट है तो 10 फैक्टोरियल हो जाएगा. 100 एलिमेंट है तो 100 फैक्टोरियल टाइम लगेगा. 200 एलिमेंट्स है तो 200 फैक्टोरियल टाइम लगेगा. सो इट्स गोइंग टू मेक इट वर्स. अगर मान लो पेटाबाइट्स ऑफ डेटा है, मान लो फेसबुक का डेटा हमें प्रोसेस करना है, ठीक है, एंड वी हैव बिलियंस ऑफ एलिमेंट्स इन द डेटा स्ट्रक्चर एंड वी हैव टू परफॉर्म एन ऑपरेशन which takes this complexity of big O of n factorial. It's going to be a worst program ever, because सदियां लग जाएंगी वो सॉल्व करने के लिए. ठीक है, instead we always have to seek the process जिसके थ्रू जब हम एल्गोरिथम लिखें और जो ऑपरेशन परफॉर्म हो n नंबर ऑफ एलिमेंट्स का, वो बिग O ऑफ 1 यानी एक सीपीयू साइकिल में सॉल्व कर दे, या फिर हद से हद log n में सॉल्व कर दे, या बिग O ऑफ n जितने नंबर ऑफ एलिमेंट्स है उतने में सॉल्व कर दे, या फिर n log n में सॉल्व कर दे. ठीक है, बट अगर n स्क्वायर 2 raised to the power n n फैक्टोरियल आ गए, इट्स गोइंग टू मेक इट वर्स्ट. ओके, क्लियर है ये बात आप सभी लोगों को? ओके, तो हमेशा आप लोगों को वो एल्गोरिथम्स यूज करनी है या लिखनी है जिनकी टाइम कॉम्प्लेक्सिटी सबसे कम है. ओके, लेट्स सी. सो आई थिंक दिस इज क्लियर. ये आपको याद होना चाहिए, ये टाइम कॉम्प्लेक्सिटी चार्ट है. ठीक है, तो सबसे अच्छी टाइम कॉम्प्लेक्सिटी कौन सी है? big of 1, then big of log n, then big of n, then big of n log n, then n square 2 raised to the power n and n factorial. Let's make a note of it. So you all open your own Trello cards, अपने अपने cards open कीजिए and specify the list of time complexities in descending order. List of time complexity in descending order. So the excellent is big O of 1. It is an excellent time complexity. Then you have big O of log n. This is also excellent time complexity. Okay. Then you have big O of n, which is good time complexity. Then you have big O of n into log n. Okay, this is fair. Then you have big O of n square, n raised to the power 2. Sorry. Number of element raised to the power 2. So this is bad. Then you have big O of 2 raised to the power n. This is also bad actually. Okay, fair.
So
that's fair. Okay, then you have 2 raised to the power n. This is also bad, or let's say it's horrible. This one is bad. This one is fair. This one is good. Okay, and big O 2 raised to the power n is horrible, and big O of n factorial, this is horrible. Is that clear? So these are your time complexities and you should know about it. So let's say given an algorithm, मतलब आपके पास मान लो एक list of algorithms available है और सबकी time complexity लिखी हुई है, ठीक है, for the same operation. तो सबसे पहले आप कौन सी algorithm select करोगे?
big O 1.
हाँ, इसकी big O 1. अगर big O 1 नहीं है तो log n वाली देखेंगे, नहीं है तो फिर big O n देखेंगे. ठीक है, so we are going to observe algorithm and its time complexity in this order. Okay, now let's have a test. Let's go down here. There are some common data structures available here. Okay, and there are certain operations. So here you have a list of data structures. You have array, you have stack, you have queue, you have linked list. Okay, and there are multiple operations. Access the data, search the data, insert the data, and delete the data. These are 4 important operations which we perform on a data structure. Okay, so what is the time complexity of array when you access an element? क्या है time complexity? Big O of 1. It is an excellent time complexity. Array के अंदर अगर आप सर्च करोगे तो कैसी है time complexity? Fair. Okay, कौन सी है? Fair. अगर आप insert करते हो तो fair. Delete करते हैं तो fair. Stack का क्या है? When you access an element from a stack, fair. When you search an element onto a stack, when you insert an element onto a stack, when you delete an element from a stack, then again for queue, single linked list, double linked list, it's similar. For stack, queue, single linked list, and double linked list, because it's an implementation of linked list only. Linked list is used for implementation of list, stack, queue, single linked list, and double linked list. Okay. Then you have a skip list. What is the time complexity of skip list in excess? O of log n. क्या है ये? What kind of complexity is it? O of log n क्या है? Good. Okay. कौन सी है ये? Good. Then you have hash table. Hash table, when you access an element from a hash table, it is big O of 1. Okay. Big O of 1 है ये भी. So when you search an element on a hash table, it's big O of 1. When you insert an element on a hash table, big O of 1. When you delete an element from this, what is the time complexity? Big O of 1. कैसी है ये complexity? Excellent. Okay. बाकी उसके बाद में आपके पास बाइनरी सर्च ट्री, कार्टेशियन ट्री, बी ट्री, आर्बिट्री, split tree, AVL tree, KD tree. There are many other data structures available. Can you tell me which data structure is the best data structure for all the operations?
Hash table.
Hash table. Hash table is the best data structure. Okay. So hash table is generally used in programming, and hash table in Python programming, there is an implementation of hash table, and that is known as dictionary. Okay. There is a data structure known as dictionary, which is an implementation of hash table. So dictionary data structure is the fastest data structure because it allows you to access, search, insert, and delete data in excellent time. Okay. Clear? समझ में आ गया? तो linked list, तो list की क्या है? When you access an element from a list, क्या है time complexity? When you access an element from a list, fair, कौन सी है बताओ? Time complexity बताओ. When you access an element from a list, what is the time complexity? Time complexity है क्या? Big O of n. When you search an element from a list,
Big O of n.
When you insert an element onto a list,
Big O of 1.
big O of 1. When you delete an element from a list,
Big O of 1.
big O of 1. Okay. But these are some basic operations. ठीक है. अब हम चलेंगे डिटेल्ड ऑपरेशन में. पहले हम लिस्ट के ऑपरेशंस में जाएंगे, फिर हम डिक्शनरी के ऑपरेशन. ठीक है. और फिर हम उन्हें विजुअलाइज करके चेक करेंगे. ओके. लेट्स सी. So let's see. There's a question. What does this NA means? Not available. NA means not available, and it is big O of 1 in hash tables case, and it's big O of log n in split tree as well as in Cartesian tree. Okay. Now let's see. So now we'll go to another URL, and that is bigocheatsheet.io. Okay. Now you are here on this resource bigocheatsheet.io. Now what you need to do here on bigocheatsheet.io, you're going to open linked list. Okay. Open your linked list operation. Now in linked list, we are going to explore single linked list. It is considered as a list. Okay. So average case and worst case. Space complexity is big O of n. It depends on number of elements you have in a list. It's going to occupy n number of spaces in the memory. Okay. Now let's come to time complexity. Okay. So now let's see. Finding an element on a list. Okay. This is one operation. You have to find an element on a list. Okay. And it is going to be big O of n. Okay. Why is that? Big O of n. Let us just quickly check. So if I take you to Visual Go, and if we have to find an element from a list, okay, let's say you have to search an element onto a list. Suppose I want to search an element 3. Okay. Or else let's say I have to search for an element known as 7. Let's see what's going to happen. So when I click on this, I'm on first element. Here you can see, if the list is empty, we are going to return not found. Otherwise, we are going to start from index 0 and the head value will be stored onto a temporary variable. Now what we are going to do, until that temporary value is equal to the value which we are searching. If temporary item is not equal to v, we are going to increment the index one by one. First, we are going to start from 0, then we'll go to 1, 2, 3, 4, 5, 6, 7, 8, 9, and we are going to read the next value into temporary until temporary is not equal to, until temporary is equal to null. Okay. So if there is no element found, we are going to return not found, or else we are going to return the index of the element if item is equal to v as soon as we get that match. Okay. Now, since you can see that this index is being incremented one by one, that means we are going to go to the first element, then we'll go to the second one, third one, fourth, 5, 6, 7, 8. Okay. So it's going to be big O of n operation because n number of elements will be involved while searching for an element. Okay. Let's observe. So I've gone to the first stage. I've checked whether this element is equal to v. So my v value is 7. So whether 8 is equal to 7? No. 8 is not equal to 7 because the element which we are searching is 7 and the current element which we have got is 8. So 8 is equal to 7. Is 8 equal to 7? 8 equal to 7? क्या हो गया भाई बांका क्या आ गया? Is 8 equal to 7? It is not equal to 7. क्या होगा? So we have to continue to the next element. Okay. Let's see. So we have gone to the first element. Is 1 equal to 7? We'll go to the next element. Is 2 equal to 7? We'll go to the next element. Is 3 equal to 7? We'll go to the next element. Is 4 equal to 7? Is 5 equal to 7? Is 6 equal to 7? Is 7 equal to 7?
Yes.
So we have found the element and we are going to return the index value. So this whole operation is big O of n because we have to travel from first element to second, then to the third, then to the fourth, then to the fifth. So irrespective of whatever item we are searching, it is going to explore that item until that item is found. So consider your item is at the last position. It's always going to be n number of operations. Okay, is that clear? तो ये कौन सा ऑपरेशन है? Identifying an element or searching an element onto a list is big O of n. Is that clear? क्योंकि जितने number of elements होंगे उतने ही बार वो चेक करेगा अगले अगले स्टेज पे. बेस्ट केस ये हो सकता है कि फर्स्ट एलिमेंट पे सर्च मिल जाए, बट ऐसा हर बार तो नहीं होगा कि फर्स्ट एलिमेंट पे फर्स्ट पोजीशन पे ही आपका एलिमेंट है जो आप सर्च कर रहे हो. एवरी टाइम इट्स नॉट गोइंग टू हैपन. ओके, सो दिस इज कंसीडर्ड एज अ बिग O of n operation because n number of operations will be done. Is that clear? Clear हो गई ये बात? चलिए let's see. So let's open one more. Let's open one more resource which is going to be list operations. Okay, open करते हैं, यहीं पे open कर लेते हैं. So let's say I'll take you to docs.python.org and we are going to consider list operations first. Okay, so here we have under data structures under 5.1 we have the list operations. Okay, so how we are going to check whether an element is in the list or not. Okay, so let me just quickly show you. So we'll go to our collaboratory here and let's call it as find an element in the list. Okay, so this operation will be known as, पहले हम एक बना लेते हैं. Let's say let's make a list of 1 2 3 4 5 6 7, and this is going to be my list 1. Okay, list 1. तो दो ऑपरेशंस हमने देखे, एक तो इंसर्ट एट द हेड, then you have insert at tail, and you have insert between any element. Okay, so we are going to find an element. So to find an element, how we check? Let's consider seven in list 1. Okay, if I want to search 7, I'm going to define it like this: find 7 in list 1. Okay, when we run, we are going to get a response true, that yes, 7 is in the list. Let's say I would try to search for any other element, 21 in list 1. So we are going to get false. So this is the finding operation. Okay, so if you want to find an element on a list, you can use in keyword. Using in, you can quickly check back if an element exists in a list. And same is for strings. Let's say I will try to check Salman in actors. Is Salman in actors? True. Yes. Salman's name was there in the actors list. But if I check Katrina in actors, I'm going to get false. No. So you can search integers, you can search strings in a list. This operation is big O of n operation. What operation is it? Big O of, कौन सा ऑपरेशन है? आप बताइए, कौन सा ऑपरेशन है ये? सलमान इन एक्टर्स. यस. सर्च फाइंडिंग एन एलिमेंट कौन सा ऑपरेशन है? क्यों? ट्रेवल पूरा ना भी करे उससे क्या फर्क पड़ता है? जरूरी थोड़ी है कि फर्स्ट पे ही, इट बी एनीवेयर. अगर फर्स्ट पे तो बिग O of 1 हो जाएगा, n नंबर ऑफ एलिमेंट से तो बिग O of n हो जाएगा. ठीक है, इफ यू हैव अ लिस्ट ऑफ n एलिमेंट्स, देन इट्स ऑलवेज गोइंग टू बी एन nth ऑपरेशन, बिग O of n. ठीक है, कौन सा है? बिग O of n. क्लियर? यहाँ तक क्लियर है? ठीक है. Now let's see. Now let's say there is another operation, insert operation. Okay, so we'll quickly explore insert on a list. So you have to insert an item at a given position. The first argument is the index of the element before which to insert. So a dot insert at 0, 0th index, and x will be the element which you want to insert. So this will insert at the front of the list. That means at the head of the list. Okay. And if you will insert at the length of the list, if you will execute this operation length of a, you're going to get total number of elements in the list. So you are going to get the last index. If you insert at the last index, it is going to be inserted at the end of the list, at the tail of the list. Okay. And this operation is also equal to append operation. Okay. If you append on a list, it's going to add a value at the end of the list. Okay. So ये दोनों operations करने से पहले I would like to take you to Visual Go just to make you understand the insert operation. So when you insert that head, okay, let's say I want to insert 44 at the head. So it's going to be big O of 1 because we created a new vertex and just we changed the previous head to the new head. That's it. It's only one single operation, irrespective of n number of elements. कौन सा ऑपरेशन है ये? big O of 1. If I insert at the end of the list, okay, at the nth element, if I want to insert 80 at the end of the element, then what's going to happen? Again, it's going to be big O of 1. You're going to create a new vertex and you're going to change the tail. So irrespective of n number of elements, कोई फर्क नहीं पड़ता कितने भी elements होने दीजिए लिस्ट में, हमें एक नया vertex बनाना है and just we need to call that vertex as that tail. Is that clear? So this is also a big O of 1 operation. When you insert at the head, it is big O of 1. When you insert at the tail, it is big O of 1. But when you insert in between any position, then it is going to be n number of operations depending on the nth position you want to insert. Okay, so let's say if I want to insert an element at a position, okay, specify both index, the first value is the index where you want to insert, and second value will be the value which you want to insert. So let's say I want to insert at 6th index value number 90. Okay, I want to insert value 90 at 6th index. So when I click on go, you can see that. We'll go to the head first. Okay, let's create a new list. Actually, I think it's already made. So I've made a new list and I would like to insert at 5th index and the value will be 95. So when I click on go, so we are going to go to the head, we're going to crawl back, we'll go to the second position, we'll check the nth index first. So it's going to be a big O of n operation. Depending on n number of elements, if you want to insert at a specific position, it's going to be big O of n. Okay, so we've gone to the 5th, we have created a new vertex, we've changed the element to that, and we have shifted the index. Is that clear? So this operation is big O of n. So inserting in between a list at a specific index is going to be big O of n. But if you insert at the top and if you insert at the tail, it's going to be big O of 1. Okay, let's go for it. So I hope you understand. Now we are going to insert the elements into list. Insert the elements into list. So first is insert at the top of the list. Top means insert at the head of the list. Okay. So you're going to use list 1. You're going to call this function insert. You're going to define the index. Index will be 0 and element will be, let's say, 20. This operation is going to be big O of, कौन सा operation होगा ये? Insert at the head of the list, big O of 1. Okay. Second, insert at the tail of the list. Okay. You're going to call list 1 dot insert. You're going you can call append as well, but let's use both the operations. So you're going to get the length of your list 1. Okay. So that means at the end of the list, okay, and we are going to insert, let's say, 30 onto the list. Okay, this is big O of, what is the operation when you insert at the tail of the list? Big O of 1. There is an alternate operation, list 1 dot append. You can append at the end as well. Let's say 30. Let's call this value as 40. This is going to be which time complexity? क्या होगी इसकी? Insert at the tail.
1. Big O 1.
क्यों? बताओ. अभिषेक बात.
इसमें हम उसको टेल कर रहे हैं, टेल के ऊपर मतलब टेल पे सेट कर रहे हैं.
हाँ, तो होगा क्या?
उससे टेल में भी ओपन लेंगे मतलब टॉप.
क्या प्रोसेस होना चाहिए? कैसे होगा प्रोसेस?
तो वो तो ऑटोमेटिकली उसकी लेंथ के एंड पे पहुंच जाएगा ना कि
कहाँ पहुंच जाएगा लेंथ
पे जाएगा ना, लेंथ की क्या नाम है जो हमारी लिस्ट है उसकी टेल पे जाएगा. तो सर नंबर ऑफ ऑपरेशंस तो वन ही होंगे ना, तो इसीलिए बिग ऑफ वन।
You are going to insert a new vertex and you have to change the tail. That's it.
सर क्या ना नंबर ऑफ ऑपरेशन वन होंगे ना।
हाँ ठीक है, कितने हो जाएगी टाइम कॉम्प्लेक्सिटी बिग ऑफ वन, ठीक है। एंड इफ यू हैव टू इंसर्ट at a position, at an index, let's say 5 in the list. Okay, if you have to insert at an index 5, okay, let's call it as 60. Now what is the time complexity for this operation? Big O of n. Is that clear? Let's print, check the contents of the list. Check the contents of the list. Okay, let's print the list. Oh, sorry. List. In the next cell, we are going to write list 1. Otherwise, it would have inserted again. Okay, so I have got this list 1, 2, 3, 4, 5, 6, 7 was the original list. I added 20 at the top. This is big O of 1. I added 30 with this operation at the end. This is also big O of 1. Then again I appended 40. This is also big O of 1, inserting at the tail of the list. And then I have inserted at the fifth index of the list. Okay. So when we added at the fifth index of the list, this is going to be big O of n operation. Is that clear? So you understand this visually, you understand this programmatically, as well as now you are clear with the operation also. Okay. And here, you know, when you find an element on a list, it's going to be big O of 1. Okay. When you add an element to the front, it is big O of 1. When you add at the back of the list, it is big O of 1. But when you add at an arbitrary index, it is going to be big O of n. Is that clear? Okay. Now let's see. Let's say now when you have to access an element at the first position, okay, when you have to access the element at the first position, so this is the search operation. Actually, we have to go for the access operation. Okay, finding element, so always it's going to be big O of n. But when you have to access an element at the first element, you're going to get that directly big O of 1. When you access an element from the last, it's going to be big O of 1. But when you access an element at an arbitrary index, it is going to be big O of n, because it has to crawl to that place. N number of elements will be involved. Okay. So let's quickly go to this. Okay, append कर दिया, extend कर दिया आपने. Now it's going to remove that. So पहले हम check कर लेते हैं access करते कैसे हैं element को. Okay, let's see. So now we are going to write another operation. Access an element from the list. So you have list 1. If you have to access the element at index 0, this is big O of 1. So element at index 0 is 20. Okay. Access the last element from the list. Okay. List 1, length of list 1. This operation is also going to be big O of 1. -1 आया ना, एक और एलिमेंट कहाँ है? So this is 40. Okay, because the index starts from 0. So when you access the last element from the list, it's going to be okay. And when you access an element from an index, from arbitrary index, it's going to be the 5. Big O of n. So it's going to be 60. So now you know how to access an element from a list. Okay. अब देखिए. Now there are some other operations. There is an operation known as remove. When you click on remove, it removes the first item from the list whose value is equal to x. So you're going to give a value. Let's say I want to remove 60. It's going to search for 60 and it's going to remove that element. So let's say in a list, if you have two 60s, so the first 60 which is encountered is going to be removed. Okay. Let's say. Let's add one more 60. Okay. Here is list 1. Let's say if I want to check the index position of 60. Okay. पहले check कर रहा हूं मैं 60 कौन सा index पे है. So 60 is at index number 5. Okay. Check index of an element in list. I would like to insert 60 at 8th index of list. Okay. List 1 dot insert on 8th index. I would like to insert an element again 60 and show the list. List 1. Okay. So now you can see we had 60 at index number 5. After 2 elements, मैंने एक और 60 इंसर्ट कर दिया. ये तो मेरा 5th इंडेक्स पे था. अब इसके बाद मैंने एक और इंसर्ट कर दिया. Just to show you that when I'm going to remove, when I'm going to call remove, only the first element will be removed. Only the first 60 element will be removed and the next one will remain same, will remain here. Okay. Let's say. So let me just mark it. So this is your first 60 at index position 5. This is at index position 8. Now we are going to remove an element from the list. अच्छा मुझे बताओ removing an element from the list का क्या होगा time complexity? Big O of n. ठीक है? Because it will travel up to the nth position on the list. ठीक है? And it's going to be big O of n. So now let's see. So list 1 dot remove, and you're going to remove, let's say 60. This operation is going to be big O of n operation, because n number of elements, depending on nth element, it is going to search for 60 and then it is going to delete it. Okay. Before we do that, if you want me to show you the remove operation here, okay, let me just run it again. Let's say. So I have this list, let's say 22, 2, 77, 6, 43, 76, 89. Let's say I want to remove 43. So I'm going to remove the element from head. You can do that. You can remove from the tail, and you can remove the element at a specific index 0, 1, 2, 3. Let's say I would like to remove it from index number 3. So when I click on go, it's going to be big O of n operation, because it will reach up to that element and then it's going to remove it. Again, if you want me to show you. Okay, let's see. So sixth element पे थे आप. Sixth element आपको हटाना है. अभी क्रॉल कर करके जाएगा जहां पे आपको एलिमेंट मिलेगा. जैसे वो एलिमेंट मिलता है उस एलिमेंट को रिमूव करेगा और इंडेक्स पोजीशन चेंज कर देगा. दिस ऑपरेशन इज गोइंग टू बी बिग O of n operation. Okay, let's see. So it's going to be big O of n. Let's show the contents of the list. So now when we do this, you can see that earlier we have two 60s. One was before 5 and another was after 6. So the list element before 5 has been removed and the second 60th element is still available in the list. So when you call remove, only first element will be removed out of the list. Yes.
आपने ऐसे रिमूव प्लेन जो पहला अगर एलिमेंट सेम है जो फर्स्ट एनकाउंटर होगा उसे रिमूव कर देंगे. सर ऐसे तो अगर मैं वो टोटली मतलब अगर 6 मुझे पूरी लिस्ट से रिमूव करना है तो कैसे करूं?
पूरी अगर तो you can create a loop से check कर सकते हो. If 60 in this list, then you can remove it again and again. Okay, so we'll do that when we come to conditions. We are going to test that. Okay, that's it. Now let's see, is that clear? Suppose, so let's say, chalo, let's take that question. Let's say he's asking remove multiple values from list. Okay, if you have to remove multiple values from list. Okay, so what you can do is you can quickly specify a for loop. Okay, you can say for I in list 1. Okay, we can write a for loop for value I in list 1, and you can check if I equal to 60. Okay, अगर I 60 है, so you can call list 1 dot remove I. Okay, so before that, let's insert some more elements. List 1 dot insert. At index 3, I'm going to add 60. Okay, list 1 dot insert. At position 6, I want to add 60, and I would like to check the contents of list 1 again. So I've got 60 available multiple times. Okay, 160, second 60, third 60. Now you can crawl in a list. You can read all the elements from the list. You can check if the element is equal to 60. You are going to remove that. Okay. Finally, we're going to show the contents of list. We call it as list 1. So when you run, now you can see that all the elements where 60 was there, it has been removed. Okay, but we are going to understand conditions in the next session, wherein we are going to explore about conditions in details. It's going to be the next topic. Okay.
बट इसमें तो खाली 60 हमने रिमूव करा है जितनी भी 60 से होते हैं बट हम 2 3 4 इस करेंगे मतलब जैसे 260 छोड़ के फिर 3 4 छोड़ के फिर 60 5 छोड़ के तो इस तरीके से सीक्वेंस में तो
conditions लगा के you can check. I'll show you that in the next session. Okay. Now let's see. So here till here is it clear? यहाँ तक आप लोगों को समझ में आ गया? Insert operation. So insert operation क्या है? इसके time complexity बताइए. What is the time complexity for this operation? Big O of n. इसी क्या है? सब लोग अपने चैट में बताइए. आप बताइए क्या है इसकी टाइम कॉम्प्लेक्सिटी? बिग O of n. ठीक है. ओके, इसकी बताइए क्या है टाइम कॉम्प्लेक्सिटी? आप बताओ. बिग O of n. ओके, क्लियर. सो यू आर क्लियर विद दिस ऑपरेशन? यहां तक क्लियर हो गया आप लोगों को? Now let's see. So insert आपको पता है, remove आपको पता है. Now you can also remove the item at a given position in the list. Okay, and you can return that element. So you are going to delete the element, and the output of this function will be the value which has been removed. You can quickly see that out. If no index is specified, a.pop removes and returns the last item in the list. Okay, so when you pop, this means you can remove from an arbitrary index, as well as if you are not going to specify a value, it's going to remove the last element from the list. Okay, is that clear? Now let's see क्या है pop operation. So let me take you to the visual representation first. So let's say we have a list here. I would like to perform pop. So when I use remove I is equal to n minus 1, that is remove from tail, that means I have not specified a value. It's going to remove the last element from the list. Okay, observe and let me know the time complexity of this. So it will go to the first, then it will go to the second one, and it will go to the third one, then it will go to the fourth one, till n number of items. What is the time complexity for this process? Big O of n. ठीक है, क्या है? Big O of n. So if you are removing the element from the last, this process is going to be big O of n. Is that clear? समझ में आ गया अब आप लोगों को? तो हेड और टेल से अगर कोई ऑपरेशन हो रहा है, so it's going to be big O of 1. But if all the elements are involved, be it search, be it insert, be it delete, it's a big O of n operation. Is that clear? ठीक है. और वो आपने देखा भी था, लिस्ट में हमने चेक किया था. When you have a list, when you access and when you search, it is big O of n. But when you insert and you delete, it's big O of 1 at the top and at the tail. But when you insert at an arbitrary index, then it's going to be big O of n. Okay, is that clear? So you should know time complexity for each of the data structures. Okay, and you should always be aware about the best data structures and where they can perform best. Okay, is that clear? So let's suppose there is a problem statement wherein you have to perform search. Okay, वहाँ पे आपको search perform करना. And somebody said you have petabytes of data and you have to perform search on that petabytes of data. So you're going to avoid any of the algorithm which has high time complexity. Okay, you have to avoid such algorithms because with the increase of size of data, the number of operations and the time consumed to perform that operation will be elongated. Okay, and your computer may seem hanged and the process may seem slow. So we avoid writing such softwares. Okay, we always want to write a software which is quick. When you insert, it's big O of 1. When you delete, it's big O of 1. Okay, you're using Trello. Trello use करते हैं आप लोग? Trello की जो algorithms हैं, these are big O of 1. So when you insert a comment, when you add an attachment, it's always big O of 1, irrespective of all other processes. Hence, it is pretty fast. Okay, clear? Now let's see. Okay, now let's see. So big O of n, this is clear to all the participants. Now let's see. I'll take you here. So we are going to perform pop operation. So when you pop from the end, it's going to be big O of n. Let's see a few more. Okay, now let's see. Suppose I want to remove from the head. So when I remove from the head, it is what operation? When I pop from the head, it is big O of 1. Why? Just you need to change the head. That's it. And you have to delete the temporary value. That's it. One operation. Changing the head is the operation. Okay. You're changing the head, and that is the only one operation which you are performing on the list. Okay. So when you delete from the top, it's going to be big O of 1. When you delete from the tail, it is going to be big O of 1. When you delete from the tail, it's going to be big O of n. Okay. And when you delete from an arbitrary index, let's say 4, let's say 3, when you delete from an arbitrary index, what operation it's going to be? Big O of n. So you're going to crawl the elements and then you're going to delete that. Is that clear? Now let's see. What? List खत्म हो जाएगी? Okay, so is that clear? Let's see. So let's go for remove items from the list. I'm going to remove items from the list. Okay, first operation. Remove from the top, from the head. Okay. So when you call remove function, you have to put value. But if you want to delete from an index, then you use pop function. Okay. So we are going to call list one dot pop, and we are going to remove from the head. Okay. Tell me, what is the time complexity of this? Big O of 1. Let's check the contents of the list. So when I pop the element, 20 has been removed out, and I'm left with 1, 2, 3, 4, 5, 6, 7, 30, and 40. This was big O of 1. Next operation. Remove an element. Remove an element from the end of list. Okay. So you're going to call list one dot pop. What is the time complexity of this operation? Big O of n. Let's check the content. List one. Okay. So you have removed it from the end, and this operation is big O of n. Okay. Now let's see. We'll remove the element from an arbitrary index. Let's say remove from an arbitrary index. Okay. So you're going to call list one dot pop, and you're going to remove from an arbitrary index. Okay. You're going to remove from an arbitrary index, list one dot pop. Okay. So let's remove from 1, 2, 3, 4, 5. Let's remove from index number 4. What will be this operation? Big O of n. Let's run it. So now you have removed 5. Okay. So this is big O of n operation. Is that clear? Is that clear to everyone? All the participants who are connected on chat or connected online, if you have any questions, please ask me. समझ में आ गया आपको? लॉजिकली भी आपको क्लियर हो गया? विजुअली इज इट क्लियर? क्या ऑपरेशंस है? अगर कभी कंफ्यूजन हो जाए, विजुअल को ओपन कीजिए एंड जस्ट ट्राई टू एनिमेट इट एंड सी व्हाट्स हैपनिंग, what all processes are being done and what is the logic behind the code. Okay, is that clear? No doubt for now. Okay, so Abhishek, Deepika, Harshita Singh, any queries? Harshita, if you have any questions, please ask me. Pawan, Shresh, Vanshi Tiwari, any question? None? Is that clear? Okay, now let's see. So we are done with these operations on list. Now let's see. So if you have to clear the items, you can quickly call clear and you can remove all the items from the list. And this is equivalent to deleting an element from the list by providing sliced information. Slicing you have done in the last session, wherein you have to provide an index and you have to provide a position. Okay, I think you have done this. Everyone has done this. So since the index is 0 and none of the position is specified, it's going to filter out all the elements from the list and it's going to delete each one of them. Okay, and this operation is going to be big O of n operation. N number of elements will be deleted. Okay, let's clear the list. Before clearing the list, let's say we are going to sort it. Okay, we are going to implement the sort function. Sort the list. It's already sorted, I guess. So let's say we are going to, okay, let's say we are going to sort it in the reverse order. So let's call help on sort function first. So whenever you have to take help, you can quickly call these, and there is an option known as reverse. So if you say reverse equal to true, it's going to sort in the descending order. Okay, so let's call list.sort and let's call reverse equal to true. So when you sort it, and let's get the content of list 1. Okay, so now you can see that this is sorted in the reverse order now. Okay, so you can call sort function. You can sort in ascending order if you don't specify reverse equal to true. If you specify reverse equal to false, it's going to sort in the ascending order. If you specify reverse equal to true, it's going to sort in the descending order. Okay, clear? So now, so here, so in the same way, if you want, you can reverse it directly also. You can call list.reverse. Okay, this is similar. Both the functions are similar. Reverse equal to true, or else you can directly call list.reverse. Okay, as well as, but it's not going to sort. It's just going to reverse the elements in the list. Okay. Then you can count the number of elements in the list, number of times an element appears in the list. Okay. So let's say if you have an element which is available multiple times. So let's insert 3 60s in the list. Okay, let's insert. List 1 dot insert. Let's say I'm going to call at index position 3, or let's say we are going to append it. Append 60. Okay. Again append 60. Again append 60. So I've appended 63 times. I've run this code 3 times. And now if I check the list content, so I've got 60, 60, 60 appended. Okay. Now I'm going to check the count of 60 in the list. Okay. List 1 dot count, and you're going to provide 60. So when you run, you can see 60 appears thrice in the list. Okay. Is that clear to everyone? So these are certain operations which you all have done over the list: sort, reverse, clear, index, pop, remove, insert, extend. Extend, you can add in an element onto the list. Let's say if you have another list, okay, list 2, and you want to add it to the list 1, you can extend the list. You can join 2 lists. What does that mean? Let's see, I'll show you. So now you're going to perform extend the list. Consider you have list 1. Okay. Let's say I'm going to call it as actors. I have a list of actors. Okay. Salman, Ranveer. Okay. And I have actress. Let's say Katrina and Deepika. Okay. Now I'm going to extend the list. I'm going to call actors.extend, and I'm going to add an actress onto the list. And I would like to print that. So now you can see that actors is now extended, and elements of list 2, which is actress, is now added onto actress. Okay. Clear? So you can join 2 different lists. Okay. Is that clear? So these are the operations.
Concatenation.
Kind of concatenation over the list. Okay. Now, let's see. Index, you already know. Indexing of list. So let's say if you have list 1, you can directly call an index. Let's say you can call index number 5. You're going to get 2 from that list. Okay. Let's do one thing. Let's just put the content of list 1 first. Let's check it out. So I have this list. I'll open a notepad. Put it here. Okay, consider this as a list. Then you have index at the bottom, positives and negatives. Let's just quickly specify that information. Index number 0, index 1, 2, index 3, index 4, 5, index position 6, index position 7, index position 8, index position 9. Then It starts from 0. So if you want to access the last element, it starts from -1. So -1, -2, -3, -4, -5, -6, -7, -8, -9, -10. It starts from -10, -9, -8, -7, -6, -5, -4, -3, -2, -1. Okay? Is that clear? Okay, these are the indexes, positives and negatives, and you have the positions also. Let's define the position. Position starts from 1. The position number 1, position number 2, position number 3, position number 4, position 5, position number 6, position 7, position 8, position 9, and position 10. Okay, then if you want to access the last element in the negative indexes, it's going to be 0. Then -1, -2, -3, -4, -5, -6, -7, -8, -9. So this position will be -9, -8, -7, -6. Okay, let's call it as negative 9, 8, 7, 6, 5, 4, 3, 2, 1, and if you don't specify a value, it's going to be 0. Okay, so these are the positions. Now let's see. So now if I want to access index position -4, let me know what value I'm going to get. Index position -4 कौन सी आएगी? -4 6 कैसा है? लिस्ट तो ये है 30 7 6 4 3 2 1. ये लिस्ट है 1 आएगा when you access -4. Okay, we are going to get 1. Let me know if I call list 1 index position -7, what is going to be the output? -7 index -7, value will be 4. Okay, now let's see. If I want to slice the elements out, slice the elements from list, I'm going to call list 1 and I want to start from index 3. Index 3 I want to start till position number 9. Let me know what's going to be the output. I'm starting from index 3. Okay, index 3 and position number 9. Tell me what's going to be the output. 4 3 2 1 66. So this should be the output, right? Let's see. So when we run this, we are going to get 4 3 2 1 66. Clear? Let's say one more example. Slice from negative index and position. List 1. So I want to slice from -8 to -1. Tell me what is going to be the output. From -8 to -1. I would like to filter from -8 index to -1 position. Okay, what's going to be the output? This should be the output. Okay, let's run that. When I run, this is going to be 6, 4, 3, 2, 1, 66. Chalo, let me know the output of this. List 1. What should be the output? Full list will come. Clear कैसे हो जाएगी?
फुल लिस्ट क्लियर करने के लिए
अभी इसमें इंडेक्स की वैल्यू क्या है बताओ?
इसमें इंडेक्स की वैल्यू
हाँ, डिफॉल्ट वैल्यू फॉर इंडेक्स इज 0 और पोजीशन की वैल्यू क्या है? वो भी 0 है ना? तो क्या आ जाएगी? 0 से लेके 0 तक आ जाएगी. So it starts from here, it will go till here. क्या आएगा आउटपुट में? You're going to get your complete list filtered out. Okay, let's run it. So I've got 37, 6, 4, 3, 2, 1, 60, 60, 60. Clear? This is known as slicing. Okay, is that clear? So I guess operations on lists are clear to everyone. So that's all for the day. We'll continue over conditions, loops in the next session tomorrow. Okay. Thank you so much for being available. Thank you so much for watching.